Morning, everyone. I'm Len Prazych of Board Converting News, Editor-in-Chief. I want to welcome you all to our very first hosted webinar on how machine learning will change the corrugated industry. Fascinating topic, compelling topic, and I appreciate you all joining me for about 45 minutes this morning. We'll be speaking with a few industry experts, content experts on this topic. And briefly, what you will be learning about the corrugated facility of the future is how machine learning is impacting this, where data is harvested and analyzed, increasing output and profit margins by orders of magnitude, and even predicting and preventing breakdowns before they happen. All important information, all relevant topics. Briefly, I will introduce our three panelists and give them a moment to add more information about that. First, we have Matthew Miller, Director of Technology at Helios. Also with us is Justin Gagne, a Senior Data Scientist with Helios. And we have Dennis Wood, Director of Manufacturing at Premier Packaging. So I'll give them all a second to tell them a little bit about themselves and then go into some questions. So if we can start with Matt, would you say a few words, please, Matt?
Sure. Hey, everyone. As Len mentioned, I'm the Director of Technology for Helios. My background has been in the machine learning, smart factory automation field from my career at GE. And, I've taken that knowledge into Sun Automation to help them build out this product.
Justin.
Hi, thank you. I'm happy to be here. My name is Justin, as you know. I've been practicing data science for a little over 7 years now in various industries. And over the last year, specifically focused in the Internet of Things, so sensor-based applications. And yeah, that's about it.
Excellent. And Dennis.
Hey, I'm Dennis Wood, Director of Manufacturing, Premier Packaging. As Len mentioned, we operate 6 sheet plants across the U.S. and are expanding to more. We've been buying a lot of new equipment in the last few years, and this is certainly a fascinating topic that I think many of my colleagues, and certainly I'm interested in where this has taken the industry.
Great, thank you. So I think the first thing we should do is actually define what is machine learning and artificial intelligence, creating a foundation for the rest of our questions to follow. Maybe we'll start with the data analyst. Justin, can you speak in English as to what this is for the rest of us?
I'll do my best. So yeah, machine learning is essentially a collection of computer algorithms that learn from their previous mistakes. That's about as simple as you can think of it. So basically, these algorithms track their error whenever they are wrong with a prediction or a classification, and then they update that information to try to do better later.
So that would be theoretically how the machines learn new and correct behaviors. Okay.
And then artificial intelligence is essentially a subset of machine learning. So all artificial intelligence is machine learning. Not all machine learning is artificial intelligence.
Got it. So Matt, how would you see this working specifically within the corrugated market, and why should we care?
Yeah, so one of the menaces of the corrugated industry is unplanned downtime. That costs, the industry average is around $1,000 an hour. Machine learning has this capability to make predictions about when that unplanned downtime may occur. It'll allow you to mitigate the issue before the machine actually comes down.
Excellent. And Dennis, you are an early adopter of the technology. Can you briefly explain how machine learning is impacted you and your plants?
Well, at this point, it's a bit in its infancy stage, if you will. So the machine learning, it's going to take some time, and it takes a dedicated workforce to really capitalize on it. It was mentioned it learning from its previous mistake. Now, the only way it can learn from its previous mistake is if gray matter lets it know its previous prediction was a mistake. So, you know, it will become more valuable over time, type of situation.
Yeah, why did you become an early adopter of the technology, and what process was involved in making that decision to invest in the equipment and the technology?
Well, it was, you know, discussions with the guys at Sun Automation and Helios that were presenting it. It harkened back to a previous time in my life when I was on submarines in the Navy, and we used not a machine learning, but you used lots of diagnostics to try to predict failure. So it's like, it's a great idea. You know, this thing can start predicting failure. Another thing it does, though, is the predicting of just normal maintenance. And I think of an example. I have the same machine, exact same machine in 3 different plants. And one is almost brand new, one is a little over a year old, another one's about 2 years old. One of them runs 3 shifts, 5 days a week. Another one runs 7 days a week, and another one last year ran 1 shift. We just expanded that operation to 2 shifts. Well, there are certain maintenance items on each of those machines that if we went 5 years ago, you would simply say, perform this every 90 days, perform this every 6 months. Well, the machine that's operating 7 days a week is going to need it significantly earlier than the machine that's running 1 shift 5 days a week. But old maintenance schedules didn't allow us to understand what, let's say, transmission oil, changing the transmission oil in the feed section. It just gave you a date. And so you would have to, as part of your maintenance program, stop and change the transmission oil. It's been 6 months or whatever the periodicity might be. Now we can look and say, well, what's the load on the feed section? How much did it actually run? And what's the burn rate on the oil? Kind of like we do in vehicles now, right? Your vehicle tells you when it's time to change your oil, not necessarily based solely on miles, type of thing. So, you know, there are early advantages there, and the advantages are going to grow as we get more information to the system, so that the system can then take our input and compare it to its data analytics.
So, Matt, at what point should box plants get involved in machine learning and begin this journey? I don't imagine it is, they say one day, let's do it, and you flip a switch and it's there tomorrow. There's got to be a learning curve, I imagine. How does that work?
Yeah, so obviously, since we sell machine learning, I would say you need to do it today. But, you know, not every box plant is completely ready for that. You know, this industry tends to be slower to adopt technology. And some plants are, you know, very behind in terms of their adoption of technology. We collect data from the PLC, and some of the older PLCs were really just glorified switches or relays. And in that case, the Helios will not work on the machine as is. So what we're releasing this quarter is what we call our sensor package. These are wireless sensors that we can affix to older machines that will interface with our Helios gateway and provide the fidelity that we need to you know, make predictions and provide that data. You know, we offer a couple different service tiers for the application. And, you know, some of our customers have said, I'm not really interested in machine learning today. I just want dashboards. I just want to see, you know, be able to analyze my data. And we have built out or purpose-built the system to be able to do that. Other customers who are more advanced technologically, they've maybe had dashboards or historians or things like that. They actually want the machine learning. They get it. They're ready to adopt it. Now, in terms of how long does it take to really onboard and begin getting some reliable predictions. Our experience, based on basically lab data, is that it typically takes 2 to 2.5 months, somewhere around there.
So there's a learning curve you would suggest that these plants experience. Justin, how are you involved in that, and how would you make that more accessible to a box plant donor thinking about investing in this technology?
Well, my involvement is, as the data scientist, I'm responsible for working with subject matter experts in the industry to identify what sensors on these machines are most valuable for these various types of predictions. Essentially, what data are we really keying in on? And then using historical data to build predictive models that help us identify when a part's about to fail or when the machine's about to have downtime. And I'm sorry, what was the second part of that question?
Yeah, well, your involvement in this and how box plants can get on board or embrace the technology.
Okay. So I would say the first way that I would recommend a company get on board would be to really start to think about their overall data stewardship. And when I talk about data stewardship, I mean, are they currently tracking their machine downtimes, for instance? And if they're not, I would recommend they do that, because sharing that information with us is going to help us really maximize the efficacy of the tools that we're building today. And, on top of just tracking it, be very precise about how you track it and add extra information like what the type of downtime was historically. We can do a lot without that information, but if we have that information at our disposal, it really will supercharge what we're building.
And Matt, you said that box plants should get involved today or immediately or as soon as possible. Might the size or scale of a box plant operation, how does it impact their decision to invest in the technology?
Size or scale, the savings that can come from correctly predicting downtime can be in the hundreds of thousands of dollars per machine. At scale, that results in potentially millions of dollars of savings in a given year. So you're going to see better results at scale, whereas if you only have a handful of machines, it's not going to do that. And I just want to add one thing. We interviewed many customers about this platform. Before we actually started building it, we were trying to validate some assumptions and get some good field knowledge. And the recurring theme that we weren't asking for, but every box plant owner that we interviewed said, my challenge is that my experienced guys are leaving the industry. They're retiring, they're aging out. And we're trying to hire qualified maintenance people, but they're either too new or not qualified enough. And so they can't go up to a machine and listen to the transmission and say, I hear that ticking, like the old guy would do. And it's going to fail. They don't know that. So their request is really to embed the knowledge of those folks who are retiring into a system so that it can assist them, the younger guys, in addressing that. So that's really where we see the value at the end of the day.
And does it matter whether it is an independent or an integrated, just in terms of size or scale? No,
there's no difference. I mean, it all depends on the pricing, and we're pretty reasonable, compared to the ROI. It's a pretty good bet that an independent or an integrated will have success with that.
Since you mentioned price, we should also ask, how much might an operation expect to invest when they say, let's go ahead and do this and let's make it work?
Yeah. We operate on a software as a service model, similar to Facebook or Twitter, where you're constantly getting improvements and features, and the app is continually growing. With our platform, because we're a software as a service provider, we actually work on an annual subscription basis. And I'm not sure what other firms are doing. I know that some actually do, perpetual licenses where you have a big upfront investment and then maintenance. Ours is the same every year. So for us, it's a $20,000 subscription. You pay that each year, and you get all the features, all brand new features that come out with it.
Okay. Dennis, how long was it before you first learned of this, or your company first learned of machine learning, and that you decided to implement it? And how long did it take before you began to see the results of that decision?
Yeah, it was decision was pretty much immediate, because we were buying new equipment. You asked Matthew about when should someone look at going with machine learning, and I think if you're buying new equipment, it is silly not to put machine learning on a brand new machine. We talk about law of unintended consequences. There are always unintended consequences. Usually we think about that being negative. In this case, it's positive. They're looking at the machine learning for purposes of predicting failure, predicting when maintenance is required, and all that. If you put it on a brand new machine, you also get the advantage of seeing degradation paths. How are different things degrading over time from the OEM original spec? Because it's recording everything that's happening with the machine. So as long as there's an output, so it sees gaps, and it sees snip pressures, it sees all sorts of things that over time we're able to then look at and make other determinations from. So it was pretty much immediate for me. We are just getting it installed and up and running now. So I can't really comment that or say that we've seen a tremendous impact. We've got a lot of stuff to do. We're in that 2.5 month period that Matthew talked about, where you've got to give some feedback to the system so the system understands when it sees an anomalous event, what did that event really mean?
Okay. And as we know, the industry is doing quite well, booming, in fact, and new machines are being put online every day at both independents and integrateds, which speaks to the reason why everyone should be buying investing in some kind of machine learning every day. But Justin, what might be some of the challenges technologically that plants would have to overcome?
I think one of the more, one challenge would be, so we have this tool, it's a software, tool. How do we get people that are on the plant floor in their day-to-day to make it part of their workflow to use it? We could be really excellent at predicting machine downtime, for instance, but if it never gets surfaced to the appropriate people until it's too late, then it's not going to be as effective. And I would say another challenge would be, these machines are very complicated. And part of what we're building is something to kind of find that needle in the haystack. But that also does take having relationships with, engineers and other subject matter experts to help, especially during that 2-month onboarding period. So yeah, I think those would be the two biggest things that come to my mind.
Yeah, and just to put an exclamation point on that, an operator that's operating a machine, they're not necessarily going to see the value of, well, why do I need to record this downtime when it happens? So it's imperative that leadership drive that behavior, because they can see the financial impact. And where we have seen the difficulty is getting that engagement from the operators.
Yeah. What about training? Also, not only engagement, they've got the ability to run a machine, and you would assume run this all, but there's obviously got to be training from top down. What is involved in that?
Yeah, I mean, we have a customer success program that actually handles that. And the training is from a high level, it's usually around how to use the less granular reporting, the things that give them some productivity metrics and operational metrics. The real training effort happens with the maintenance and middle management. They're the ones who are going to be using the data from the tool more than any other. In the near future, we'll be implementing what we call remote monitoring. It's a lot of effort on the part of the customer to be able to look at the data and evaluate what's going on and make informed decisions. We'll have Sun personnel who will actually monitor Helios on their behalf, and say they see a parts order or a part that's needed based on maintenance. They'll pick up the phone, call the customer, and arrange to have that shipped out to them. So it's going to be a very valuable service, and I think it's going to help alleviate some of those manpower issues that we're seeing. For the operator, it's relatively, we've built it with some relative ease, in that it's a couple of clicks when downtime happens, so that they can indicate that this has happened. What really streamlines it, though, is integration with say a Kiwi or an Amtech that's recording downtime. That's already in the operator's workflow. They're already keying in why the machine stopped or what have you, and we can harvest that data so that they don't have to actually plug it into the Helios system.
Excellent.
Len, if I can comment on that, as far as the people in the training, we've recognized how valuable this can be to us in the future. I'm actually adding positions on in corporate roles to support the implementation and getting all of these things into the system so that we can capitalize on it. So I think, at least for me, it's going to take someone from the corporate level who is dedicated to the plants in a service capacity to get the most out of this.
Yeah, I agree wholeheartedly.
Excellent. Do you think maybe, and given the labor shortages, concerns, hiring people, retaining people, will some of this machine learning and or artificial intelligence replace humans, or allow us to use less human interaction on these machines? All of you can speak to that, please.
Yeah, I'm not looking at it from the standpoint of reducing headcount. However, if you can get more output, if you can plan your maintenance events around normally scheduled downtime versus the machine stopping itself and now you have to do it, then you require less human hours. And one of the things that the COVID period has shown us is the workers have reevaluated their lives a lot, and they want more family time. They want a better balance. 20 years ago, when I was younger and earlier in my career, lots of workers, they wanted to work every Saturday. They wanted to work 10s, maximum overtime. Everybody was looking for that. Today, they're not looking for that. They're looking for better work-life balance. So having a tool that gives us better uptime means less overtime necessary. I can run more stuff Monday through Friday. People can have every weekend off. So not a headcount reduction, but a better quality of life for the associates that are running the equipment.
Justin, can you weigh in on that?
It's a common question I've heard, being involved in data science for a number of years, even outside of IoT applications, people are worried that, you know, the computer will replace us all. And I would say that, you know, I could see some long-term dystopian future where that might be true, but it's going to be a long time before we get there. And kind of going off what Dennis said, you know, really it's just about maximizing the efficiency on the plant floor and saving money. I mean, our tools will tell you when a machine is unhappy or potentially going to go down. You still need a human to step in and intercede at that point, you know. So really all we're doing is we're collecting all of the thousands of sensors that are putting out telemetry data on these machines, and we're putting it into a format that's digestible and actionable.
Is it all machines on the plant floor, or certain machines, or some better able to get usable data, actionable data?
At this point, we are just focused on the corrugated machines.
I mean, the actual corrugator.
Yeah, on the actual corrugators. And we do support a number of different manufacturers at this point, and we're constantly working to grow that. And we do have plans in the works for extending to other aspects along, you know, that whole assembly line. So we do want to grow outside of just the corrugators in the future. Yeah.
Okay. Matt, anything to add to that?
Yeah, I'll second, you know, what Justin and Dennis are saying. You know, I'm kind of a student of this. You know, there are economists that, you know, on one side, you know, claim that, you know, that this is just technology like this will just enable businesses to allocate these resources to more value add type of work, right? And that's largely what we see. But then there are the doomsday economists that, you know, they believe that, you know, that there's going to be a great exodus, you know, from the workforce, and we're going to have to figure out, you know, from a government standpoint and from an economy, how do we, you know, sustain those folks from the value that the machines are producing for us.
I can hear our listeners now thinking of the many questions they'll be asking you during the Q&A, and I know we're only touching on a few of these topics because of our limited time. Anyone who's listening are also seeing surveys that are being sent out while we are doing this webinar, so that we can gauge some of their response as well. So thank you everyone in advance for doing that. So I just want to get a little clarity on this, Matt. So it's only on corrugators that we are working now, not flexos, die cutters, anything?
Yeah, no, it's actually the opposite. I'm sorry, I didn't pick up on that. Yeah, it's actually on the converting machines. Corrugators are, you know, on the roadmap, but right now it is just the converting machines.
Oh, okay. So whether it's any size flexo or die cutter, folder gluers, so all of those machines capable of having that data.
Yeah, that's true.
Okay. And Dennis, so far, I know it's early in the adoption phase. What do you think it was that convinced you in Premier Packaging to invest in this and make the
other than what I talked about before, which is I recognize that there's direct value in it, and then there's future learnings value, and there's the need to, you know, if you just do some simple math, and if you said, you know, we're running sheet plants, they're all sheet plants, so we run shorter orders, so more setup time. But if a machine is, to make math easy, producing boxes 50% of the time, and 50% of the time it's either in setup or down for maintenance or something. If you can cut downtime by 5%, you increased your output by 10%. So the math of decreasing downtime, it has a significant impact on your total output. And you know, uptime is everything now. As a matter of fact, On 2022 goals, all my people's goals involve asset utilization. What is your uptime? You've got to focus on uptime. Demand is still pretty heavy in our industry. It's been crazy for the last 2 years. And, they're not expecting it to get slow for a while. So the more uptime, the more profits, the better asset utilization, obviously the better profits. So those are the things that convinced me. The other thing that convinced me, I've done a lot of things with Sun Automation, and they're behind Helios. I have a lot of confidence in what they're doing. So they've been a great partner for me.
Excellent. And I know you have multiple locations. Is these machine learning installed in all of them? Can it be managed individually, or do you have a headquarters that would oversee all of the operations?
Right. So they're in 3 of the plants where new machines went in the last year or so. They'll be going in with any new machines. We're now talking about what we need to do to get the equipment on existing machines. The new machines were already brands that Helios had developed the interface with. So now we've got to look at machines that we do not have the interface or were not initially developed interfaces and get them put on those machines. So it'll roll out to other locations. I mentioned before hiring and creating a new group on my corporate team to manage and make sure we can capitalize on this investment and help us with our asset utilization, if you will, the uptime.
And Justin, what might be the one thing you would tell or advise a box plant who is considering machine learning to know before making this investment?
Artificial intelligence is simply a tool that's based on the data it's given. So, what Helios does is we make the collection of the sensor data seamless, and we can take on, 15,000 data points per second per machine, right? And we try to make heads or tails out of that data. However, going back to a previous point I made, the historical, being a good steward of your historical data is so valuable. And I think it's something that most places that want to adopt machine learning get wrong at first. And so collecting good downtime historical data is probably one of the most valuable things you can do in the corrugated industry if you plan to later adopt machine learning to help you get better at predicting downtimes.
Matt, anything that you can add to that as we go into the final stages of this webinar?
Yeah, no, I agree with, Justin, the being a good steward of your data beforehand is really important. We have, certain firms either outside the industry or in the industry have endeavored to produce a machine learning type of platform, but where they started was just collecting data. And in some cases, they weren't collecting the right data. So they were collecting data from the machines and from the subject matter experts, but it wasn't the right data. And now they're trying to convert into, a machine learning platform, and they're struggling pretty mightily with it.
All right. I think I've got everything. I've got more questions. I'm sure our listeners do. And I will leave it up to them to ask questions of you individually or me as a moderator. And I'm not a robot yet, even though some of my parts are artificial. I think that might be a concern for some people of the future, the corrugated plant of the future, having robots walking around the facility. And we see much of it is automated now. So if there's anything else that either of you can add to close this, I'm thinking we're close to time here.
Len, one of the one of the things that is important to me about all of this, it's not just where it is today, but it's being part of it early enough for where it can go. And I mean, our industry is going to move to smart bearings and smart motors and things that we're going to start getting input from things we can't get input today. And I want to make sure that we're part of it. So when things change over the next 5 and 10 years, we're not dealing with being behind the curve at that point. So I can just see this going in so many different directions beyond. There's going to be things that we'll be able to do with this type of stuff 10 years from now that we can't even think about today.
Yeah, I agree with that. I think, machine learning is in its infancy. This product's relatively new, but those who lag in it in the long term, they're going to find that those who have not are differentiated in the marketplace to a point where it's heavily they're very far ahead of those who haven't.
Anything to wrap up, Justin? Final thoughts? You are not a robot?
To my knowledge, I'm not a robot. No, I thank you for your time. This is, at least for me, a really fascinating problem to work on. Yeah, I would agree with the other folks here that early adoption is really one of the best things you can do, because 5 years from now, those that did adopt early are going to be miles ahead of those who lagged.
Great. Thank you all. I will open the floor up to questions now from our listeners. Thank you all again. All right, everybody. Thanks a lot. That was great. I learned a lot even the second time around, and the questions have been flowing in. So we'll start and see what we have to say here. First question. Machine learning is no doubt the next step for the industry, but how will you take this data to create a message to the OEM that a part might be needed, check inventory, etc.? Is it simply an API between Helios and the OEM? And Matt, I guess you'd be the first to hit that.
Yeah, I can take that. So here's my thought on that. We actually are purpose building Helios because it is a product of Sun Automation to communicate with our parts department or aftermarket department to be able to automatically dispatch parts, dispatch service people. Right now, we're in what we call a concierge model, where they're manually monitoring it for consumable needs and then pushing out quotes when they see the need. But the goal here is, complete cooperation with all of the OEMs. We can't provide parts, for a Mitsubishi or for BOPS, but we hope that they will engage with us at a certain point and allow us to push that information to them via, as your questioner described, an API or something along those lines.
Okay. Here's a question on electricity consumption, which I hadn't considered, but of course, certainly a consideration and an expense. Do you capture electricity consumption, and what insights do you draw from this data and energy efficiency? So that could be Justin and or Dennis on this.
Well, we are tracking very closely if machines are up or down. So, I guess you could it would be an easy step to go from there to, the amount of electricity consumed. Right now, our primary focus is on part failure predictions and machine downtime predictions. So it's not, on our immediate roadmap, but that is a really interesting thought that we might spend some time on.
And Dennis, have you measured energy consumption so far at any of the 3 locations you're running this at?
Have not. New concept there. Hadn't really thought about energy consumption. Certainly, we see load on the system, corresponding to, are you running E flute versus running C flute? You see more load on the drive for the feed section. So we could certainly extrapolate something from there, but not specifically looking at kilowatts consumed.
Okay. And actually, another question just came in specifically for you. So here we go. Dennis, what machines did you start with, and do you plan to have all of your manufacturing equipment with machine learning capabilities?
Yep. So I'll answer the second half first. No, I'm not going to take a machine that's very ancillary, maybe an old 4-bar or 6-bar slitter scorer. We're not going to put machine learning on that. Certainly, any of the flexo folder gluers, any of the rotary die cutters, those we're definitely going to have it on. Naturally, the new machines first. It's easier to do. They already are set up to give you lots of outputs from their electronics. So it's a lot easier, but ultimately, yeah, I'd love to have it on all the machines, because I mentioned before, there's a lot more we're going to find that we can get from this data than simply predicting failure and getting parts ordered. We're going to learn a lot. It records the data, it records every bit of data. So there's stuff there that we're not doing anything with at this point.
Got it. Matt, is the price per machine monitored?
The price per machine monitored?
That says, that's the question. So the price per machine, how much each machine, the machine learning component is costing each machine specifically?
Yeah, I mean, we can, sorry, I didn't mean to interrupt you. Yeah, if I'm following the question or not, this may be different. I see that as tracking the ROI, right? And we use on the Helios website, you can go, there is an ROI calculator that you can plug in the information about your machines and your shifts and what your tolerance level is for things, and it'll give you an ROI. We do watch that. We actually, for each of our customers, we do a case study when they're considering this and demonstrate to them what savings they can find from it. So it's definitely is something that is key to us, and rightfully so, because it's a sales tool for us.
Okay. And someone mentioned this during the webinar, working with either Kiwi or Amtech. The question has been, could you do Kiwi or Amtech cross-reporting to validate the data?
Yeah, Kiwi and Amtech are actually, their data is rocket fuel for predictive capability. As Justin talked about, you're marrying up operating data and what they call target data, which is, Kiwi downtime events. And that just offers us a treasure trove of each downtime and what the cause of the downtime was. And when you marry that with the operating data, you can ultimately begin to predict based on that. We've had a lot of success with particularly Kiwi. We're also, in looking at Amtech to potentially make some noise there as well. Yeah, I think that's answering the question.
Okay. And how receptive have plants been to this technology? Does it get them excited, skeptical, confused? What is the general consensus thus far?
The response when we came out initially was pretty strong. And like any technology hype curve, if you're familiar, you get a huge amount of interest, and then it's a trough that goes down, and folks don't see the application per se. But once we released our case studies actually to our customers, they're very interested. There's a keen level of interest and an excitement around partnering with Sun to build out their predictive capability in their plans.
Yeah, and Dennis, have you been asked about how this is going, or have you shared this with any of your peers in the industry?
A little bit here and there, maybe at an AICC meeting or something, talking about it. But as I mentioned in the earlier portion, it's still infancy stage. There's still a lot of input we have to tell the system. And I get it. It's a challenge. Somebody has to do that. That's why I need some staff at the corporate level. I can't have an operator spending all his time putting in information, because then he's going to have to record a downtime event for putting in downtime information. Not what we want. We want the machine running. So we want it to be relatively seamless for the operator and someone outside the directly operating that is supporting getting the additional information in the system. Because as Justin mentioned, the data tells you there's an anomaly, but the data can't tell you what the anomaly was until you start giving it some more information. So say, wait a minute, I saw this set of data in the past somewhere, and this and here's what you said happened when I saw this set of data. I'm seeing this set of data coming again. And so there's a good bit going on there, but a few people are talking about it. It's certainly a subject that's a topic in the broader industry. What's all this data going to do for us? Our machines put out a tremendous amount of information constantly.
Okay, here's a couple of the same question. What exactly has the monitoring told you about machine operation and maintenance? I guess kind of general, but it can be drilled down a little bit.
Yeah, I think Justin and I could probably take that. From a commercial standpoint, the data has really shown us that customers could be getting more life out of their consumables. One example is anvil blankets. We track the cover thickness, and we can monitor the trend, and we can see or see in the data when the blankets are replaced. And sometimes they're replaced with 20% still remaining, 30% still remaining. And that added up over the course of a year can typically cover the cost of the subscription right there. So you've broken even at that point. So yeah, that's it. And Justin's been, obviously more in the weeds on the data. He may have some insights as well.
Yeah, Justin.
Yeah, sure. I mean, Matt's answer was really good, honestly. I mean, that's one of the main ways that we can is, instead of just going by some, cadence of we've always replaced this part at this frequency, we can give you much more precise insights on the wear of that part. But also we can kind of give you that more holistic, view overall on the machine. So, we look at frequency of downtime or percentage of downtime, and we see that, for some folks, it's a 2%, overall downtime. And then some folks, they might have machines that go down up to 50%. So we can really easily identify the machines that are basically thrashing versus the machines that are operating healthily. So that might be another advantage.
Okay, related. Why would a 5% decrease in downtime result in a 10% increase in productivity?
I guess I should have explained my math a little more. If you're up times 50% and your downtime's 50%, then I go to 55% uptime. That's 10% more output. I went from 50 to 55.
Okay.
Oh yeah, that makes sense.
All right, that was to Dennis. I'm sorry, I didn't see that part there. Okay.
I'd given that example of how downtime impacts your output, or a reduction in downtime impacts your output.
All right, thanks for that clarification. Here's another one. Does this machine learning obviously require a dedicated internet connection for each machine in the plant? Or is it networked somehow?
We require an internet connection. That can be through one of two things. Either each gateway connects to the network and traverses that network to get to the internet, or we also come enabled with cellular, so you can avoid the whole issue of having the network drop there. Now, a lot of customers, and what we recommend is that we actually go with a network drop. from the plant as opposed to a cellular connection, for security reasons and also reliability reasons. We find that cellular, it's good when it's good, it's bad when it's bad, and we see it across the board. So, yeah, it does require that. And the primary reason, just to make sure everybody's on the same page, is this is a cloud-based solution. We process and store the data in the cloud, and then serve it up back to the customer through a number of ways: a website, a mobile site, and then an API that customers can actually query the data from the Helios cloud for ingestion into their own systems.
And you did mention a very important factor in this is the security. What would a box plant who is considering this technology need to know about the security concerns? Is my data out there? Can it be intercepted? Can I be, malware, etc.?
Yeah. There are 2 points there. First of all, we use Amazon Web Services, so they have a part in security through how they secure their platform, and they're typically the gold standard. And then the other piece is what we develop. The firmware on the gateway. We need to demonstrate that it's hardened, that it's can't be penetrated. The encryption of the data as it traverses the internet. Is it a substantial level? And we use a pretty substantial level of encryption. And then how are we encrypting the data in the cloud itself? When it's at rest.
Okay. Looks like we have time for a couple of more. Here's one. Why do we have to download key in this data from our plant data collection systems? And can you write the APIs to these various ERP systems? 2-part question, sounds like.
Yeah. The answer is we can. We do that where we can. A good example is, say an Amtech solution. If we're integrated with them and downtime's being captured, that does not, change their workflow. It's not additional keystrokes, but it provides that. That's ultimately what we want to get to, is not having to key in information unless it's already part of their workflow to make that happen.
Okay. And finally, to wrap up, how long has this technology been available? I'm thinking for a lot of our viewers, listeners, it is a relatively new concept, and we have the surveys coming in also that explain that or show that this is indeed the case. So this is new. How long has it been around?
Justin, how long's machine learning been available?
Well, you
Not
mean
just ours, obviously, but just machine learning capabilities in general.
well, some of the first AI advancements go back as early as the 1950s. Modern AI, though, I would say it's been in the last 10 years that it's really started to be adopted in various industries, and that has been with the advent of things like cloud computing. It's a lot easier for folks to securely share data, and also computers have just gotten a lot more powerful. So it's a lot easier to crunch lots and lots of data. The data we get from these machines, it is big data. I mentioned earlier, it's up to 15 to 20,000 data points per second per machine. So the volume of data is huge. And that's one reason why computers are better at analyzing it than humans. So yeah, I would say in industries like ours, 5 to 10 years, maybe.
Yeah. And the Helios product has only been available for a year as of this month. And the interesting thing is, when we started, we did not possess the predictive capability. It takes some time to really build that out in a substantial way. We were predicting consumable replacements and things like that, but the real, machine learning, heavy duty downtime prediction, we've actually just seen that come to play, where we're able to develop case studies for customers as of December.
Got it. All right, gentlemen, I want to thank you very much, Dennis, Matt, Justin, and everyone who joined this morning, taking an hour out of your busy Monday mornings. Greatly appreciate that. I know we've only scratched the surface here, and you'll certainly be hearing more from us in the future about this. You have all our contact information if you want to address any of us individually, and you can continue reading Board Converting News. By the way, your March 28th issue should be in your mailbox and or online right now. So get to it, get to the rest of your Monday. Thanks so much for your readership, support. Our experts, thank you guys. Can't appreciate it enough. All right, we're out. Thank you all. Bye-bye.
Thank you.
Yeah.